Now let's run the solver again and generate sensitivity report for this transportation problem. So let's go back into solver, okay, and we'll solve it again. Now this time we're going to request the answer and the sensitivity report. Now you remember, answer report is the same as what we see in the model page, except that it is organized in a table format. So total cost and the values and the constraints, whether they are binding or non-binding. So here all the constraints are binding except for plant 2, where we are not shipping all of the capacity. So plant 2, we have capacity of 600, we are only shipping 300. And let's look at the sensitivity report. Sensitivity report, remember we discussed this way back in chapter 3. The first table gives you the sensitivity of the objective coefficients. So this is the cost of transportation from plants to the different regions, and how much increase and how much decrease is allowed from that value for the current optimum solution to be optimum, or the current shipping plan to remain as the best shipping plan. So here 1 E plus 30 here means infinity. That's a very, very large number. So allowable increase and allowable decrease from that. So that's a sensitivity analysis for the objective function. And here these are the sensitivity analysis values for the constraints. And for the constraints, what we have is what is called shadow prices. Shadow price indicates how much the objective function, in our case is the total cost, how much the best total cost, the minimum total cost change for unit change in the right hand side value of the constraint. So total received in region 1, that's your demand. If the demand goes up by 1 unit, then this is what the total shipping cost for the entire problem will go up by. Same here and same here and same here. And here for plant 1, if the capacity of the plant 1 goes up by 1 unit, the shadow price tells us, this being negative, it shows us that the total shipping cost will go down by $119. And same for plant 3, if the capacity of plant 3 goes up by 1 unit, the total shipping cost for the entire problem will go down by $72. And all of these shadow prices will be valid as long as the right hand side of the constraints change within these allowed increase and allowed decrease limits. So that's our sensitivity analysis report. Now we can also run solver table. So suppose if we want to change the demand by the same percentage amount, I'm going to make some changes so that we can run a solver table if the demand of all the 4 regions go up or down by a certain percentage. Okay, let's insert 2 rows here. Okay. Now this is the original demand, so let's copy that over here and we'll call this original demand. Then we will use percentage change as a single input value. Right now we'll use 0%. So the actual demand is now going to be, so I'm going to erase that and instead use, okay, let's give names first. Let's name this as original demand and this is percentage change. Okay, so our actual demand is original demand times 1 plus the percentage change. Okay. Now, having made this change, we can now run solver. Okay. Now we can run solver table, and we can change this percentage and see what will happen to our optimum solution as the demand either decreases by a certain amount or increases by a certain amount by the same percentage amount for all the 4 regions. So open solver table and enable macros. Okay, then run solver table. Okay, we're going to do a one-way table and percentage change, and we're going to use minus 20%, so that will be 0.2, to a maximum value of 30%, that will be plus 0.3, in increments of 5%, so that will be 0.05. And we will request only the total cost as the output. Click OK. Now you see the solver table report, and the last two are infeasible because we do not have sufficient capacity to meet the total demand if it goes up by 25% or 30%. Okay, up to 20% increase in demand we can handle, and these are the costs.